Okay, we want to look at the symmetry of functions, and symmetry is something is symmetrical if you can slice it in half and one side looks like the other side, right? So you can see how these are symmetrical. In algebra, there's a way to test symmetry. Either is it symmetric around the x-axis, or is it symmetric around the y-axis, or is it symmetric about the origin? What I've always done is it looks like it's a mirror, right? So this looks like you put a mirror on this axis. So to be able to do this is you would test each one of these. So I'm going to test to see if it's symmetric with the x-axis. And it says replace y with negative y. So where I see a y, I'm going to put a negative y. 5x squared minus 4. And that's going to give me negative 3y equals 5x squared minus 4. And that is not the same as the original function. So this function apparently is not symmetric about the x-axis. Well, let's check the y-axis. The y-axis says to replace x with negative x. So 3y equals 5. Replace x with negative x squared. I get 3y equals a negative and a negative is a positive. So that'll be a positive x squared minus 4. And yes, so this is symmetric with the y-axis. To be complete, you should always check if it's symmetric with the origin as well. So with the origin, you replace both y and your x's with the negative. Minus 4. I get negative 3y equals 5x squared minus 4. So this certainly does not look the same. Now, what you really should do with these type functions is graph them. I mean, the best thing is always to graph, and if you have a graphing calculator, or you can use Desmos.com, and I can go in and put in that equation 3y equals 5x squared minus 4, and I can certainly see that it looks like there is a mirror on this axis. Now, what you'll get after a while is you'll kind of figure out, you know, the thing of if you have something you're plugging in and it's to an even power, then you're probably, whatever you're looking at, the x or the y, negative and negative is going to be a positive. So let's look at one like this. So I'm going to test this one. I'm going to test it for the x-axis, which is where I replace the y. So 5x to the 4th plus 3 equals negative, oops, I forgot my negative, negative y squared. And as I can see, 5x to the 4th plus 3, negative y times negative y is a positive y. So yes, this checks with the x-axis. I'm going to check it with the y-axis, replacing my x. So I have 5 negative x to the 4th plus 3 equals y squared. This means negative x times negative x times negative x times a negative x, right? So negative x, 2, 3, 4. Well, when you multiply these two, you're going to get a positive. These two, you're going to get a positive. Positive times a positive. So that is going to be positive. And we can see this one checks for the y-axis. Well, now let's check the origin. So I'm going to plug both. My x as negative, my y as negative. And this is where hopefully you're kind of seeing if these powers are even. This actually would be all three, and definitely would check the graph to see what this looks like. 5x to the 4th plus 3 equals y squared. And I can certainly see that it looks like there is a mirror based off of my x-axis, because the left and the right look the same. It looks like there's a mirror based off of my based off of my x-axis. Sorry, I couldn't get the right letter there. And can even see in this case that there is something going on with the origin based on my algebra. And that's symmetry.